Good morning, everybody. So today we will be entering chapter 8, which is on physical optics. Alright, so this is quite a long chapter and somewhat confusing, but let's get through this lah. Okay, so the first subtopic is on Huygens Principle. I don't know how to pronounce that, but that's the spelling lah. Okay, so in this subtopic you should be able to state what is Huygens Principle, which includes spherical and plane wave fronts. Okay, and then the second one, you should be able to sketch and explain the wavefront of light after passing through a single slit and an obstacle using the principle lah. Alright, okay, so let's look onto the principle. Now, wavefronts is defined as a line or surface in the path of a wave motion in which the disturbances at every point, which is this one, have the same phase lah. Okay, so the same phase meaning if this is going up, this point must also go up for them to have the same phase. Okay, and then this is what we called a wavefront of sinusoidal waves lah. Okay, so the line joining all this point A, B, and C, O, D, E, and F are showing that they are in phase lah. Okay, now the wavefront is always perpendicular to the direction of wave propagation. So for example, so the wave is going to the left and the wavefront will be perpendicular to the wave propagation. Alright, okay, now there are several types of wavefronts. So the first one is what we call a circular wavefront, and then this is produced by a point source lah. Okay, so this is the source, so it generates two-dimensional waves saja. Okay, and then the distance between this is what we call the wavelength. And then we have the spherical wavefront. So this is produced by a point source which generates a three-dimensional waves lah. Okay, this is basically like 2D, but it is now in 3D. Okay, so this is a drawing on paper. This is where we can see the inside as well. Okay, now we also have what we call a plane wavefront. So this one is produced by a point source which generates a three-dimensional wave at a larger distance from the source. Okay, so it is further away from the source lah. So that is what we call a plane wavefront. And then we have okay, so that is basically the types of wavefronts. And then let's look at ray. Ray pula, it is defined as a line that represents the direction of travel of a wave lah. Okay, so it is at a right angle to the wavefront as shown below. Okay, so if the wave is if the wavefront is like this, which is this one here, this is the wavefront. Okay, so they are telling us that the ray is telling us the direction of travel of a wave lah. Okay, so if the wave is going to the right, the ray punya line, the straight line, should point towards the direction of the wave. Okay, alright. And then we have beam of light. So this is basically, I'm telling you about the terminologies lah. We have wavefronts, and then we have ray, and then we have the beam of light. Okay, so the third one is a beam of light. So it is a collection of rays, or what we call a column of light lah. Okay, so we have a parallel beam, divergent beam, and convergent beam. For example, a laser is a type of parallel beam lah. Okay, and then we have divergent beam, which diverts away from the source. Okay, and then convergent beam is a beam that points towards a single point. Okay, let's look at I've googled how to pronounce it. It's Huygen. Okay, so let's look at the Huygens Principle. It states that every point on a wavefront itself can be considered as a source of secondary wavelets. Okay, so the first wavefront, the first point of each of the wavefront is a source lah. Okay, So this source will cause the production of a new wavefront. Okay, so this new wavefront, it will be the tangent to all of the other wavefront lah. Okay, so let's look at some of the applications of Huygens principle right now. The construction of new wavefront for a plane wave. Okay, so let's look at that. So now, if the wave speed is v in time t, the distance traveled by the wavelet is just this one here. Okay, so from Huygens, I think it was Huygens. Okay, so from Huygens principle, points P1, P2, P3, and P4 are the wavefront A, B. Okay, sorry. Okay, so from Huygens principle, point P1, P2, P3, and P4 on wavefront A, B are the sources of the secondary wavelets. Okay, so now this is the source. Okay, so it is the source to create another wavefront di depan dia. Okay, so from the points we can draw a curve of radius s lah, which is this one. Okay, so we can then draw a straight line AB, which is the tangent to the curve at point Q1, Q2, Q3, and Q4. Okay, Q1 ni, ini maksudnya this is our circle, this is a tangent. Okay, and then each one of this lah. Okay, so hence line AB here is the new wavefront after a few seconds lah. Okay, right, so that is one of the application. We can then determine the construction of new wavefront for a plane wave lah. Okay, and then we can look at it, we can also apply it for a circular wave. Okay, so it is the explanation is the same, but then the wavefront A, B is a curve instead of a flat, instead of a straight line lah. Okay, so it is a curve, which is this one here. So it would be touching point Q1, Q2, Q3, Q3, and Q4. Okay, so this curve is the new circular wavefront after a few seconds lah. Alright, then lastly we can look at it at apply it for diffraction of wave at a single slit. We know that the Huygens principle can be used to explain the diffraction of wave. So each of the point act as a secondary source of wavelet. Okay, so the tangent, which is this one, okay, so the tangent to the wavelets from point 2, 3, and 4 is a plane wavefront, which is here. Okay, but at the edges, which is at point 1 and 5, are the last point that causes a production of wavelets. Okay, so Huygens principle suggests that in conforming to the curved shape of the wavelets near the edges, the new wavefront would bend. Okay, so it won't be in a straight line, it would bend at the end here. Okay, so it would diffract kind of around the edges here lah. Okay, so that is after it passes this single slit here lah. Okay, so there is a formation of it kind of diffract around the edges. Itu saja lah. Okay, that is for diffraction of wave at a single slit. Alright, and okay, so yeah, subtopic 1 is just basically about the theory part, which is on Huygens Principle lah. Okay, so what you need to know is Huygens Principle is basically telling us that every point on a wavefront would act as a source of a secondary wavelets lah. Okay, so the new wavefront is basically the tangent to all of them lah. Alright, okay, and then that is on our first subtopic.